Good morning, everybody. Welcome to this Pilz webinar on myPNOZ. My name is Paul Littler, and I'm a control system design engineer at Pilz. Assisting me today is Dave Scott and Alex Bryce. They will be answering any questions you have during this webinar. We will also have a questions and answer section at the end where I can cover the common questions that have been asked during the webinar, and any that are useful or perhaps easier to show everybody so everybody has the same understanding. There's the handout section for downloading of information, and then there's obviously the question section for them to help you along. So let's start the webinar. So what we're going to do in this webinar, we're going to look at the new myPNOZ. We're going to look at its uses, how to order it. We'll go through a worked example of the system, how to build up the requirements to achieve a new configuration. As I've already mentioned, if you have any questions or remarks, please enter them in the questions section where they will answer them as they go along. Don't worry if something at first doesn't make any sense or if you don't understand it, as I'll hopefully go along and explain it further into the slides. This webinar is an introduction and is aimed at everybody needing to do the steps from ordering, configuring, installing or upgrading the system. So it tries to cover everything. Slides for this presentation and the myPNOZ flyer are available to download in the handouts, like I said, and a recording of the presentation will be sent to you approximately 3 hours after the session and will also be available for viewing on our webinar channel. So what is myPNOZ? Well, it's a modular safety relay that is manufactured individually in one assembly in accordance with your specific requirements, yet it remains still flexible and adaptable and changeable. There are three main steps to achieving this. Step number one, you create your order. Using the myPNOZ configurator in the eShop on the Pilz website, you can create your specific requirement and place it on order. Step two, we at Pilz receive this order and we can build the assembly. We then configure it to your requirements and test it. It's then passed through to dispatch for shipment to yourselves. Finally, step three, you receive the product, fit it into your safety related control system with a minimum of fuss, then commission and validate your system. So where does the product sit within the Pilz range? It's aimed mainly to sit between the standalone safety relays and the multi-programmable relays. myPNOZ is a technical evolution of classic safety relays. It is not a slimmed down version of the programmable safety solution like the PNOZ Multi. It should therefore always be used for simple safety solutions and not for complex applications. It's not so much the number of input functions that can be used, but rather the possibility of logically linking these functions together. It is best suited for compact machines and systems with a clear safety requirement. For instance, 2 to 16 inputs, simple logic functions, no linking with other parts of plant or mechanical parts, machine parts. Above all, contact expansions and integration of time-delayed outputs, switch on and switch off delay, are easy to implement with the myPNOZ. This means, for example, everything that was previously achieved by the conventional wiring of several safety relays, partly with special functions, for example, two-handed control, delay times and bridging of one or more units, is suited to this system. Taking a relatively simple configuration of a machine press requiring all the safety circuits to be healthy to operate, a standard PNOZ Sigma configuration would involve a separate PNOZ Sigma for each function, emergency stop, safety gate, light curtain, two-handed control, bridging them together into another safety relay to give the resultant control signal. With a myPNOZ configuration, this would be condensed down into a single unit comprising of 3 modules. The main advantages are then a smaller footprint. At 47.5mm, the myPNOZ is over half the width of the 97.5mm PNOZ Sigma configuration. Wiring. The installation time at approximately only 25 wire connections for the myPNOZ. This again is over half the amount of wiring, approximately 55 wiring connections on the PNOZ Sigma configuration. Finally, another advantage of the myPNOZ is for the timing of signals. This has an influence on the calculations of safe distances for light curtains and two-handed controls. A summary of the system features and specifics is shown here. I won't go through everything, but basically the myPNOZ device has 12 units available. It starts off with a head module, which is 17.5mm in width, which supplies the power supply for up to 8 expansion modules. It has an integrated global safety function, for example, an emergency stop, which will affect all the outputs on the system. There are 4 types of input module, each one 12.5mm in width, and they can be and linked together to take 2 signals in, or all linked together to take 2 safety channels in. You can monitor two-handed devices of type 3A and 3C, and they will be AND linked with another function. Logically ANDed with a global safety function, as mentioned, from the head module, influences effects of the next output module. So all input modules influence the following output module, and then with another input module afterwards, another output module would be required. Within an input module, you can have all linked safety functions, and they are always AND linked with other safety functions of the same zone. There are 4 types of output module, again 17.5mm. Following are relay and semiconductor outputs. They are also programmable to have delay on and delay off timers. When an input module allows for an output module, when an input module follows an output module, a new safety zone is created. There is also 4 types of combined input and output module, again 17.5mm, and they will monitor and action on the same device. Again, relay and semiconductor outputs are available, and again, programmable with on and off delays. So in summary, the main things to note are the system must start with a head module and finish with an output or an in-out module. All diagnostics are via LEDs on the modules themselves. There are 2 test pulses on the head module which are assigned to the input channels and are used for the entire system. Output switching signal device or OSSD inputs are also available to be used. Dual channel input functions. However, it is possible to use single channel, but it remains a 2 input signal on the device. Also, the safety level is reduced for a single channel device over a dual channel device. Output modules can have optional delays on and off and can be combined as desired. Single modules can be removed without dismantling adjacent modules or the bus connector. With a maximum of 8 modules, the more outputs you put on, the fewer input functions which will be available. All linked only for the inputs on the same module, or different zones. You would have to take a wire from an output of the zone, take it in as an input into the next zone. So, as I said, the head module generates 2 test pulse signals. These are used for all the inputs that are configured to use test pulses and not OSSD inputs. Input number 1, which is generally on terminals S11 and S21, are assigned to use test pulse 1. Input channel 2 on terminals S12 and S22 are assigned to use test pulse 2. Both test pulses turn off for 4 milliseconds every 200 milliseconds, with an offset between the 2 test pulses of 100 milliseconds. There must not be a delay of the signal for more than 5 milliseconds between the test pulse being generated and the input seeing that same test pulse. The logical switching threshold of the input modules is 11 volts DC, for an on signal and 5 volt DC for an off signal. Obviously, ideally, it would be 0 and 24. Otherwise, the module may not switch as expected. The input channels can also use OSSD signals or 24 volts instead of those testable signals. The OSSD generating device must not perform a switch-off test that lasts more than 1 millisecond, else the system could see it as an off signal. If a device is only a single channel, then with it set as an OSSD signal, the second input can be connected to the first, as shown in the small schematic in the middle. The myPNOZ will still work correctly and it will still be seen as a dual channel device. Obviously, the performance level of the whole system will be changed because a single device is coming in, not a double device. With the exception of a two-handed control type 3C, anti-valiant contacts, or in other words, normally open, normally closed changeover, cannot be used. With two-handed controls, the other inputs on the zone must be activated before the two-hand control is operated. Otherwise, the two-handed control will have to be released and reoperated before it is activated and starts the zone. According to the standards, the two-handed actuators are monitored for similarity, the time that both inputs have to be the same, within 500 milliseconds of each other. Any inputs into the myPNOZ that is not going to be used must be connected to a 24 volt DC. Any terminal marked UN or ground must be connected to the required potential. It is also a requirement to have all the modules using a common ground terminal to allow for common reference points and not for allowing floating signals. Onto the outputs now. There are no switch on tests performed on the outputs. However, there are switch off tests. These have a maximum length of 500 milliseconds and occur approximately every 4 seconds. The feedback loops are not tested after the output is switched on. A high signal at the feedback circuit is only required for switching on. Thus, if the feedback circuit monitoring is not required, it can be deactivated by applying a continuous 24 volt DC supply to the feedback input. Each output is internally protected by an electronic fused temperature monitor and additionally by an internal fuse. The fused temperature monitor switches off the output in the case of an overload. In the case of a massive overload, not being protected by the internal monitoring system, the internal fuse interrupts the output connection. In this case, the module must be replaced. It's not repairable. Module replacements. The modules can be replaced and the configuration changed. We won't go into changing the configuration in this webinar as it's more involved. We will, however, explain how to replace a like-for-like unit. To replace a like-for-like unit, you remove the power to the system, then simply unplug the connectors to the module to be removed and also the one to the left. This allows the module to slide out. You unlock the module by loosening the fastening clamps. Then it can be simply pulled upwards out of the assembly. The bus connector will remain on the neighbouring modules, and the new module can now be inserted from above into the guide rails of the neighbouring modules and pushed down onto the mounting rail and bus. This automatically inserts the bus connector. Just lock the module, plug in the connectors, set the rotary switches to match the original component, replace the power, and that's it. So we've been talking about zones, and this is how the myPNOZ is split into controlled sections. So what is a zone? A zone is an independent acting part of the machine or an installation. Independent means that the zone is not affected by things happening in other zones or other areas. Zones are separated from each other either by space or a stop device inside the zone, for example, a safety gate. The other zones will remain without effect, and only a global function will affect every zone. With the myPNOZ, we are able to realise such different zones with one application just by the specific use of the different modules and the order in which they are used. Most safety devices can be used with the myPNOZ system, either via the use of the volt-free switching and the test pulses generated by the myPNOZ system, or by the device having OSSD outputs. myPNOZ Creator is available online and it's integrated directly into the eShop. Don't worry if you're not registered to use it. You only need to be registered if you want to order directly. There's 13 billion configurations of hardware, and it's one simple configuration tool to generate it. The configurator can be used by yourselves to order the device directly or give the information to a third party after your configuration, for example, if you're using a distributor. Existing product codes can be entered to automatically rebuild the system. This allows for then repeat ordering of the same configuration or the modification of an existing system. The configurator allows you to build up the required system using the built-in logic or hardware editors. It is possible to simulate the operation online to confirm that the system will operate as you expect. When you enter the myPNOZ configurator on the Pilz website, you get straight through to this configuration page. So I'm going to go through now the inputs and the outputs to show you the options that are available to you. We will then go obviously through a worked example. So this is just showing you what is available. On selecting the Add Input button on the left of the zone, the Input Properties window appears and it allows you to configure the properties of the input signal. The options available to you come from a drop-down box, and you add the safety function. You have the option of an e-stop, where you'd fit an emergency stop device, a light curtain for light curtain devices, a safety gate for a safety gate or a guard switch device, an enabling switch for enabling control device, a two-handed control for a two-handed control device, and there's an unspecified device as well, which allows you to take any other sort of input device. You also have the OR connection. The OR statement will take two inputs through an OR block into the zone, where it will then be AND with the other signals. The next item to choose is how the device is started and run and reset. So from the Start Type and Test Pulse drop-down option, the following input signals and Startup Test Pulse reset options are available. By default, when you've added an input, Invalid will be chosen by default to force you to make another selection. There are then two options, Test Pulse or OSSD. This configures the input signals to the safety device to that format. Finally, the options for Start and Reset input terminal to reset that signal when it becomes healthy. Automatic allows for an automatic reset when the input signal is healthy. Rising edge requires a rising edge to be seen on the reset signal before the healthy signal is passed through, and a rising and falling edge requires a rising and falling edge, as if, for instance, a push button reset. There is also the option to have a startup test where the input device must be tested on power up of the system. Then a rising edge must be seen at the start reset input. This is useful for guarding systems where guards must be proven to be operational before the machine can be used. The next item is the equipment identifier, so you can name the signal. The text box defaults to the zone number and the input signal. For example, shown here, zone 1, input 1. You can change this to have up to 7 characters to label it, and the description box allows you to give any description of any further information you need to remember about the signal. Once the input has been generated, you'll have the option to delete the element, which will allow you to delete the item if you need to. Now looking at the output options, on selecting the Add Output button on the right-hand side of the zone, the Output Properties window appears, which allows you to configure the properties of the output signal. The first option drop-down box is the Select Output function, where you have the option to choose a relay, which is obviously volt-free contacts, and semiconductor, which is a 24-volt DC output. The volt-free relay has 3 channels by default, and is internally dual channel device. Terminals 17 to 18, 27 to 28 and 37 to 38 will all be switched at the same time. Any unused semiconductor outputs, generally you have 2 per output device, will be available to that zone, and they will automatically be added later if you do not program them, if you only program the first channel. From the drop-down option box, the following output types are then available. No delay, the output will switch instantaneous with the signal. Off delay, the output remains on for a set time before deactivating, and this is settable in steps from 0 to 300 seconds. On delay, the output remains on delay, the output remains off for a set amount of time before activating, settable in steps from 0 to 180 seconds. And a delay time available to set the delay time if delay option is chosen. Times can easily be adjusted on a site later with the rotary switches. So you don't have to worry if you don't know what times you need to have set into the system when you order it. They are freely configurable on site. The off delay timer will continue to function even if the zone device becomes healthy again. The on delay timer will not complete if the zone device becomes unhealthy during its cycle. It will then restart on the next healthy zone signal. The equipment identifier, along with the input one, also defaults to the zone number and output, the zone 1, output 1. The description box again allows you to add any description, and once this is done, the delete element will be available, which will allow you to delete the output signal. The status field. At the top left of the configurator is a status field. This changes as the configuration is modified to show whether the created configuration is functional or whether it contains errors. This, however, only refers to the system execution and not the actual safety functions of your safety-related control system. The configurator does not carry out a safety assessment of the system and cannot evaluate whether the configuration meets the required safety levels. The status check only refers to the function and execution of the logic system. There's an example here of the 4 status signals, warnings, an error, and valid validation. At the bottom left of the configurator is a help button. It can have a small dot message indicator that indicates that further information about the message appearing in the status field is also available here in the help area. Opening up the help normally will just give you some information about the logic configurator. Opening up the help when it has an orange dot will give you help about the error, or when you have a red dot, a help about the error as well. So this is going to be the worked through example that we show, which will allow us to see the system here and work through how to build it up, check it, and the ordering configuration that's allowed for it. This is a simple palletizer example, and this example only serves to illustrate the device functions and possibilities, and by no means claims to be complete in terms of safety or design. So we have calculated that there are 3 areas that need controlling separately, and these are called Zone 1, Zone 2, and Zone 3. In Zone 1, a process control safety gate, SG1, allows close access to the robot. If this door is opened and the robot is operational, then the light curtain, LC1, will trip the system, requiring the robot to stop. If either the safety gate or light curtain are not tripped, then the system will continue to operate. There is also another light curtain, LC2, for the pallet export. This stops access back into the robot cell. In Zone 2, a light curtain, LC3, allows a forklift to enter by tripping the feeder area. Then finally, in Zone 3, a safety switch, SS1, can be opened to allow access to the product. This will just stop the conveyor. We'll now configure this into the myPNOZ configurator. So going back to the logic editor, I find it easier to program the outputs first, so I've gone and selected Add Output. This opens up the configuration window and allows us to program it. I'm going to put in a relay output and I'm going to call it main, as this will switch the main supplies signals to the devices. HI0 is the header module input 0 button for the input. For this example, we'll use the emergency stop, calling it ES1, with a push button reset causing a rising and falling edge reset signal. We will set it to use test pulses as opposed to 24 volt DC. On the left hand side of the window, you can see the devices that are actually in use. You have a green box, and not shown at the moment you will have a blue box. They will show whether the input is using test pulses or OSSD. Choosing the add input button, for the palletizer example, we will use the OR connection for 2 of the inputs. Choosing the zone 1 input 1, we will choose the light curtain LC1, and it will have an automatic reset signal, and it's set for OSSD inputs to use 24 volts as opposed to the test pulses. We're then using the zone 1 input 2 button. We will use the safety gate SG1 with an automatic reset signal set for OSSD to use 24 volts as opposed to test pulses. Finally, we will add the last part of the zone, for the palletizer. We'll use the light curtain input LC2 with a rising edge reset signal, again set for OSSD. That is zone 1 completed. The E-stop will stop the zone. Either the light curtain of the robot or the safety gate being unhealthy. If both of them are unhealthy, your system will trip. If one of them is healthy, the system won't. And finally, if somebody walks backwards into the robot cell, again, the light curtain will trip the system. So now we have made that zone, we can click on the Add Zone button and we can continue configuring the system. Again, I prefer to start from the output, so I use the Add Output button. This allows the configurator window to open, and I'm going to use a semiconductor output, calling it the feeder, as this will switch the control signals to the feeder. I will also add a second output for a delayed signal. So the first signal could be used for, say, a drive stop condition, and the second signal here can be used for a power off signal. For the palletizer example, we'll use a semiconductor output again, but we will delay it and have it as a switch off signal for 2 seconds delay. On the left hand side, the first input is already programmed us. It is the E-stop that is on the head module that affects, as said previously, all zones. For the palletizer example, we'll add another input called the light curtain LC3 with an automatic reset signal, again OSSD to use 24 volts. Zone 2 is now also a completed section. However, we have one more zone to add, so we will select the plus button again to add a new zone. Adding the Add Output button opens up the operator configuration window again, and we will choose another semiconductor output which will control the conveyors. Adding the input, we will add the safety gate input, calling it SS1 with an automatic reset signal to use OSSD inputs. And again, the head module can also be seen as coming in as a control for that zone. Zone 3 is now a completed section. We now have the show hardware information, as all the logic is converted into the hardware when we press this button. All the hardware has now been calculated, and we will progress through the other options that are available to you in the logic editor. There is an option at this point to build a system using the hardware editor. We've just used the logic editor, but the hardware editor is not as simple to use and so will not be shown here. If you have an existing system that needs modification or a different type of module, this editor may be of use. Using the information button, the modules can be selected and its technical details reviewed. The hardware rotary switches. The configuration of the logic and the timers is controlled from the rotary switches on the front of the modules. The setting positions of the rotary switches on the front of the modules is displayed. They can be changed in the future. However, there is a configuration sequence that must be applied for the configuration to be used. As mentioned earlier, if you're replacing a unit, ideally you'd set the switches to the same position as previous, slide it in, and no configuration would be used. If you are to replace devices, then the configuration would have to be reprogrammed. The timer is functional and it can be changed during use with the power off to allow it to be set to a different value. The next option is the wiring view, and a simplistic wiring diagram is generated showing all the inputs and their potentials. ePlan has macros available in its data portal for the myPNOZ devices. Registering free with ePlan and their ePulse allows access to DFX files for the macros of all the Pilz devices. So in this example, if we start off on the left-hand module, the head module, it can be seen that we have a red and a black wire. These are your supply potentials. To the left of that, we have a yellow terminal. This is the start reset signal for conditions switch 11 and 20, 21, 22, I can't read it from here. And to the left of that is the emergency stop, which we're using test pulses for, and they are shown as the two green inputs. Below the module are the test pulse signals for that device and any other devices on the system that use test pulses. And on the left of that is a output for a standard signal. Starting off at zone 1, we have all our devices. We have light curtain 1, light curtain 2, and safety gate 1, powering up the relay output. It also has start and stop signals for every single one of the input devices and a common feedback signal for the output device. The zone 2 has the light curtain and its start signal, has power supply for the unit and output signals, and then there is feedback for the two signals on the output, one of them the delayed one and one of them the instantaneous one. Finally, on zone 3, again we have the supply and we have the safety switch 1, again OSSD, and at the bottom we have the two inputs for, at the bottom we have the two outputs for the two zones. We haven't actually programmed the second zone, it was added in automatically, and then the conveyor output is the one we programmed. Again, at the top there's the set reset signal for the input. So it's a simplistic drawing, and this will be available in the paperwork you receive and also available as a PDF, which we'll show in a few minutes. Switching over to the switch off matrix, there's a matrix which will show all the healthy options and the off options for the zone. For example, on the zone 1, if all inputs are healthy, the zone will be healthy. If the e-stop becomes unhealthy, no matter what any of the other signals are doing, the zone will become unhealthy. There's then the OR statement. So if light curtain 1 and safety gate 1 are opposite to each other, this signal will be healthy. However, if both of them are off, the output becomes unhealthy. And finally, if light curtain 2 is broken, the output becomes unhealthy. And this is shown again on the other two slides for the other two zones. Next is the order summary. And in the order summary, you can view the terminals and choose between cage clamp and screw terminals. You can also order no terminals. If you have an existing system and you want to replace a module, you already have the terminals included with your original system. You can choose to select copy code. This takes the configuration code into the clipboard for future use or to share. As mentioned earlier, this is the information you can give to a distributor to order the same component that you've just developed. Selecting the Create PDF file will generate a PDF documentation with all the information we have done so far included to explain the system. And finally, there's an Export Configuration button, and this, amongst other things, generates an XML file for use with ePlan. So this is an example of the palletizer example, the PDF being generated. The first page shows the overview and the components and information. The second page shows a simple logic signals. The third page then shows the wiring. The fourth page shows the switch off matrix, and then there's the default back page. Going back to the logic editor, there is an option to play the simulation. This allows the logic to be tested in the editor to check that it achieves the required operation. During the playback, the button changes to stop simulation, which will obviously exit the simulation. Again, it can be seen now we've gone back in that unprogrammed output on zone 3 has been assigned by the system. This is an example of the system in run. The top left-hand part of the slide will show the default status when you come into it. Pressing on any of the emergency stop signals within any of the logic zones, which is the global input signal, which affects all the zones will switch off as shown in the top right-hand window. Any e-stop can then be pressed again, simulating that the emergency stop has been released. A reset signal now becomes available as shown in the lower right window as a little blue switch signal. You can press the close reset and you can see that it then changes to open reset because we are looking for the rising and falling edge. As shown in the bottom left window, pressing the open reset returns the system to normal and you repeat the system as it goes round again. You can also obviously operate any of the other devices to see how it actually operates. Green generally shows the system item is active, yellow shows it is ready to start, and red shows it is triggered into a safe state. So I hope that's covered enough of the system, and what we will do now is I will have a look at the questions that have been generated and I see if we can follow up with any of those. Okay, so we have a question. We have, with myPNOZ, does it only give single output, or if you had 4 inputs, can I output each healthy input and an input for all healthy? Okay, you'd have to have separate zones. And what you would do is you'd have the inputs coming in and you can pass the signals through. So one zone would be an input, which would switch off the output. Second input would switch off second output, third output, and so on. And then you could probably use the second channel to come back into the first channel. With the myPNOZ, you only give single output, or if you have 4 inputs, can I output each healthy input? No. Yeah, so each output has to be individually switched, which means each input would have to be a separate zone. With an output for all 4 healthy state. Oh, right, okay, sorry, Robert, I'm just reading your email. I didn't realise there's second ones down. I haven't had this window open. Okay. Are all inputs only digital? Yes, they are digital. Like I said, they are either test pulse or OSSD. Barriered. There's no ATEX approval or anything on any of the devices. You would have to have a separate barrier. For reliability modelling, does each block have a failure rate? The Pascal calculations they've either been done now and will be available obviously on Pascal for you to fit, but the device itself will have its specifications. So what someone answered, as with all Pilz devices, it is externally certified, yes. So we have external testing on all our equipment so that all devices will be performance level devices. Can you advise the current load rating the relay output? I will check back up on that, but I believe there is a 6 amp rating on the outputs shareable between the outputs on that zone, but we'll find out about that and be able to come back to you on that one. Assume there'll be an update for Pascal. Yes, obviously yes, Pascal will be updated to allow for all these devices. Costs, well, obviously that would depend upon what you're doing. That's been answered. What diagnostic networks are available? At this moment in time, the only diagnostics available to you on the system are via the LEDs. If the system modules available separately in Pascal. Okay. I haven't used the Pascal yet, so I don't know if the components are separate or whether you build up a complete system. Why would you use a myPNOZ system over a myPNOZ multi? One of the main advantages is for simplicity and the option that the customer yourselves may not want to have a programming solution, so you can have the hardwired solution this way. Is there a 110 volt version? No, at the moment it's only 24 volts. Which way would there be to monitor which e-stop devices are tripped via a PLC? I do believe, let me go back a couple of slides and look at the output wiring. I do believe if we look at this one, we have standard outputs on each zone. So you would be able, I believe you can use the standard output to say that this zone is active or tripped. So you wouldn't be able to say individually which signal, but you would be able to say which zone had been tripped. So if you have the zones joined together, obviously you can separate them out slightly differently from that. Will each signal system have a unique serial number? Yes. The serial number will be printed on the side of the device, but the order number will be the same as any of the devices that you've ordered the same. The order number is built up in such a way as there's a checksum built into it, and then there's identification of every module and every rotary switch position, and that's why the product code can become quite long. Okay, I think that's covered most questions a thing. So what I'm going to do is just remind you that the handouts are available for download, and we'll stay online for another 10 minutes to allow you to download those items. Thank you for your interest in the myPNOZ product. We have some myPNOZ test rigs that can be brought to your site to show you the system, and if you wish to see them, please contact your sales people for any further information. Thank you very much.